Hey, hello, welcome back. Glad you made it back here. It is hot, and that's why I changed my background because I thought I'd give you the feeling of some fresh air with water and shading in the background. Best time to talk about heating, cooling, air conditioning and ventilation systems in Honeybee. I'm by far not an expert on this. I'm by far an expert on this. I'm by far not an expert on this. I'm not an expert on it. Note. I can only basically show you how to apply the tool to your room and to your honeybee model. But yeah, if you are an engineer and you already have some, if you are an engineer and you already have some experience with these things, then please help us. Or it's gonna be very easy for you to understand because it's very straightforward. For the people who like me who never worked with these systems before, it's gonna be a bit more intimidating, but we will try our best to go through. And it could be some of these tools where I procrastinate until the last moment to test it out, and then just to realize that it's actually not that difficult. Before we jump in, channel member shout out. I'm so proud. Third channel member, welcome to the team, Mr. Mohsin Hassan. I'm really proud and I completely missed it. I supposed to do this shout out already in the last video. I do it now. Apologize and thank you for joining. It means a lot to me. Together with my two other channel members, Koma45 and Melvina, you partly make this video possible, and I'm on the road to sustain this channel a bit better. Again, thanks a lot. Mohsin also has a channel, a video up there 5 years ago, one video. Well, doesn't really matter. You're here, that's great, part of the team. If you have any question, please let me know, and that's why you joined. I can always help you, or at least I will try if I can. And of course, so channel members will be prioritized when it comes to questions and answers from my side. And I'm also always happy to, of course, help out with your projects, and if you have any issues there and if you have questions, I'm more than happy to check it out and talk and discuss it with you guys. If you want to become a channel member, please go to my channel page, and there you can find a button membership or join. I think join. That's basically it. Again, thanks a lot, and let's jump into Honeybee. Okay, well, we haven't really checked out our energy balance in the previous video. We looked at schedules, and today we will look at air-conditioned systems. I will delete this stuff here because we covered schedules now, and here there's also schedules, lots of stuff flying around here. Here we have our program, and very quickly before we jump into HVAC, which is heating, ventilation, air condition and cooling, very quickly in loads, we haven't touched everything here yet. Some parts were actually part of creating the program type. So for example, the infiltration we discussed in length, and then we also discussed the set point, and now ventilation. There's a ventilation. We didn't really discuss ventilation, so we haven't really touched on that we could add this here, but I thought it's very straightforward. We discussed a lot here. The only thing we might want to revisit at some point is the daylight control. That is something you actually apply to your rooms, similar to these heating and ventilation and air conditioning systems. You actually apply them to a room and rather than to a program. So you see, you go with your room in here, and then you apply whatever is happening in that tool to the room or to a set of rooms. So that's somehow a bit of the difference between program type and these systems. Alright, so just before we jump into the heating, ventilation, air conditioning, cooling systems, just a word on it. Again, I'm not an expert really. For me it's actually pretty hard to understand everything. As an engineer you might have a better grasp really, but we will try our best. It's relatively simple on how you apply it, but then what it does is it's a bit different. But yeah, there are different systems, and we can have a look what they do. And now for real. So I'll try to make this video pretty short because it's not a big deal really, except that you have to have an understanding of these systems. They are partly explained, except for the first one. I'm not 100% sure what that means, but let's see. Basically, it just lists different air conditioned systems. They are all the same really to apply. You can apply them to one room or to a set of rooms. There's not really any difference on how you apply these. It's more about the knowledge on what system you want to use or can use, but we can go through one by one and see what the difference are. The first one, for me, it seems like it's an ideal air system, which you can apply to, again, you can apply these to one room or several rooms, or to your whole Honeybee model if you want. So ideal air, I was looking online and I think I found the right description talking about the Energy Plus IDF objects. And it says here, the simplest piece of zone equipment is the zone HVAC ideal loads air system component. It is used in situations where the user wishes to study the performance of a building without modeling a full HVAC system. In such a case, the ideal loads air system is usually the sole conditioning components. The user does not need to specify air loops, water loops, etc. All that is needed for the ideal system are zone controls, zone equipment configurations, and the ideal loads system component. Meaning, okay, it's a customized, simplified version of a air conditioning or air conditioning system, which you can try to work with. And actually, as you can see, you have only one mandatory input, is the rooms, and the rest is all it's just optional. And you could go now through each of these. If you hover over, it actually tells you exactly what what effect the input will have. So for example, the economizer. Text to indicate the type of air side economizer used on the ideal air system. Economizer will mix in a greater amount of outdoor air to cool the zone, the room, rather than running the cooling system. When the zone needs cooling and the outdoor air is cooler than the zone, choose from the options. Sorry, I need to read it properly, for you to understand. Economizers will mix in greater amount of outdoor air to cool the zone rather than running the cooling system. When the zone needs cooling and the outdoor air is cooler than the zone. Means that it will only cool if the outdoor air is not sufficient cooling. It's not sufficient to cool the room, then it will actually run the cooling system. That's how I understand it. Okay. But on how you apply it, it's very simple. So we could apply it now to everything, to all our rooms. And as you know, we have our rooms, our different areas here. These are all different rooms of the building. We combine these and then apply stuff to it, and then solve the adjacency of these combined room blocks. And here we applied the windows, and now we could, in addition to that, we could apply this system, this Honeybee ideal air system. I'll just plug this in here. It turns green, means there's no problem. And now if I, of course, put this in here, it will rerun the whole calculation. And now I did this too early because I wanted to see if there's a change. And nothing went red. It means it seemed it worked. The question now is really, what did it change anything? Or what did it actually change? And we will go through results later in another video, in the next video. But just very quickly, there is this tool here called Honeybee Read HVAC Sizing that you can apply to your output from your Open Studio model. So the output of your Open Studio model, the SQL output here, can apply this here. And now you see that there was that it has some sort of output. So for example, okay, bathroom, bedroom, ensuite, entry, hallway, and so on and so on. So these are all the rooms. And then we have the peak cooling, heating, and component types. And you can see here ideal load air system, district heating, component properties, and values, component values. Okay, we will go through this in another video. It's just wanted to show you that it definitely had it had some sort of effect on the rooms. But don't ask me. Everything else we will look up later on. But I could put this here, and so again, yeah, I will just leave this here, and we will discuss that at some point. Now we have several of these systems. So instead of using this system here, we could also use a different system, and it works exactly the same. Just apply the room or rooms, and then go into our Honeybee model. And we could, of course, apply it only for a certain section, you know. We could only apply a certain HVAC system to only this portion, or to only one specific room. I will not delete it now. I'll just first read what's written here. All air systems provide both ventilation and satisfaction of heating and cooling demand with the same stream of warm and cool air. As such, they are often grant tight control over zone humidity. However, because such systems often involve the cooling of air only to reheat it again, they are often more energy intense than systems that separate ventilation from the meeting of thermal loads. Okay, so a different system basically. And here you also need to provide the system type. As you remember, here we didn't have to add any additional information, but here we need to provide a system type. And the system types are here, the all air HVAC templates. So we need to have this. And from here we can choose the system we want to apply. And I mean, don't ask me, I have no clue. There's loads of different systems, and I can really just choose whatever. So you can choose your system, the system you have in your building, or if you build a new one, then you will probably think about what kind of system you want, and then you can apply that. Now it turned gray, that means we can start to use it. And now I can just run it through my Honeybee model. Yeah, so, not that easy. It's actually, I got a problem with this, realizing that in my energy balance, now cooling and heating actually, they kind of interfere with this tool. So if I want to have cooling calculated with my load balance, then I'm getting an error. Yeah, already falling into a trap. Now realizing, okay, if I apply this HVAC system to my model, then kind of interfere with what I set up as a typology for my rooms with the cooling and heating. So cooling and heating actually creates here a problem. I get an error. So if I disconnect cooling, it turns gray and it works again. It kind of makes sense that my HVAC system interferes, of course, now with the output here, the cooling and heating, because I also apply it to all the rooms, and that overrides anything I have set before as cooling and heating system. For a tutorial, is probably 20 minutes is way too short to go through each of these different systems. So that's something you need to check yourself really, and just try to understand what system do you have at home. That would be the best example. No, you choose a system in place and test that in order to learn on what kind of systems are there and how they work. I can't really tell you more. I'm also just trying to understand it. Nevertheless, so we moving on. There is several more. Again, so this is the all air template. I kind of understand what it does, but then how it works with the Open Studio and this we still need to find out. So with the energy balance, that would be interesting. So we're kind of losing these numbers here. So we're losing the energy balance here, but gain it back here. So trying to get a grasp on it. But let's step by step. One, we can only solve always just smaller components of a problem in order to solve the whole problem. I will delete this one because with this we don't need. And again, always read what's written here. It's very important. You get an understanding what that tool actually does. And now we can try a different one. This is the DOSA HVAC system. Apply a dedicated outdoor air system. DOAS system separate minimum ventilation supply from the satisfaction of heating plus cooling demand. Ventilation air tends to be supplied at neutral temperatures close to room air temperature, and heating and cooling loads are met with additional pieces of zone equipment, fan coil units as an example. Because DOAS systems only have to cool down and reheat the minimum ventilation air, they tend to use less energy than all air systems. They also tend to use less energy to distribute heating plus cooling by pumping around hot, cold water or refrigerant instead of blowing hot or cold air. However, they do not provide as good of control over humidity, and so they may not be appropriate for rooms with high latent loads like auditoriums, kitchens, and laundromats. Okay, so you see there are different systems. I'm learning a lot here, so we could apply this. It's going to be the same again. So we put our rooms. We need to again choose a system type. Again, there's probably loads of it, hundreds of different systems. Okay, there's a bit less. Again, I mean, okay, let's choose any of these really. Turn this off. I'm gonna apply my system, and then I can apply it to the rooms. And it's always the same. It's always the same game, really. It's just the matter of like what system you want to apply or you want to study. And now again, it's calculating. Again, we will find out how we can apply this to the energy balance, because at the moment that heating and cooling is actually missing. It's currently separated, so it would be interesting how that works. And the last one, no, there are two more. So this is again another type. Apply template system that only supplies heating and or cooling, no ventilation to Honeybee rooms. These systems are only designed to satisfy heating and cooling demand, and they cannot meet any minimum ventilation requirements. As such, these systems tend to be used in residential or storage settings where meeting minimum ventilation requirements may not be required, or the density of occupation is so low that infiltration is enough to meet fresh air demand. Okay, so again, another system. Here we can again have templates. We can choose from a lot of different systems here. I'm not rerunning this. By now you should know how it works. And then we also have here SHW system. So this is something different. Apply a template service hot water system to Honeybee rooms. Note that the rooms must have hot water loads assigned to them in order for them to be connected to the system, okay, so that would be now the question. If I use this one, let's choose the electric water heater. Okay, this is my system. I can apply all the rooms, but I assume that it only then has an effect on rooms which have water loads applied, which are probably only some of them. I guess the kitchen, for example, in that case. In our case, we haven't applied any other program or any other specific program to the other rooms, so I can imagine that either my apartment, mid-rise apartment program applies water loads to all the rooms. I doubt that, but yeah, we can try and also see how that has an effect on the cooling and heating. That would be interesting. I'm not sure if it makes sense to replace it, or is it a tool which you use together. Maybe also possible. But let's remove this here just for test, in order to test it, and we can run that again. Yeah, that worked. And now, okay. Yes, that already of course has an effect then on the hot water. Let's see if I can apply the cooling here. Yes, I can. Heating, yes. Okay, so this is it's a completely different system, which only has an effect on the water. So I assume I could then run this together with with any of these HVAC systems. Crazy stuff. I think I need to really read more about it, but I assume you know now how to apply it to your model and to your rooms, and if you're an engineer, you probably know way more about it, and it should be fairly easy for you to grasp. All right. Okay. Hot. I don't have a system. I only have hot and cold water and heating. Yeah, I have heating, but I don't have cooling. That's the issue. Anyway, thanks for joining again. Next time we finally will look into results and simulations and stuff like that. And then we will hopefully also get a better understanding of these HVAC systems. HVAC systems. Heating and cooling. Again, if you know more, help us. It would be nice to get a better understanding. Of course, we could all read a bit more, but then at the same time, it's not that easy to find proper texts about it online. I guess there are books, and maybe in the Open Studio documentation we can read more about it. Anyway, thanks for watching, and see you next time.